So far, we can think about permutation calculations as separated into three groups. The first would be permutations with repetition, or that would be where repetition is permitted. And in that case, your permutations is just equal to the number of sets of events, or n factorial. The second category would be permutations without repetition. And in that case, it's going to look a little different. Because repetition leaves the amount of possibilities the same for each set event, we can say that the number of permutations is equal to the number of cases or sets or objects to the number of objects chosen, or the R value. And then finally, we have permutations with identical objects, where the number of permutations is equal to n factorial over R factorial, where the n factorial refers to all the objects in the set, and the R factorial refers to the object that is repeated, or in this case, has an identical object to it in the set. Sometimes we want to arrange things in a very specific order. In fact, it's so specific that it restricts, and we're going to underline that word here, the way we want them to be arranged. Sometimes we may want something to be set first, or that same thing to be set last. When we have such specifications, we are now dealing with permutations with restrictions. And that is often a combination of these two formulas over here, and I'm circling them. And of course, this formula over here, that pertains to when we have a restriction with an identical or repeated set. So I'll just write identical or repeated set within the permutation, or the numbers in the permutation. Either way, we're going to expand this formula here and adjust it according to the restrictions mentioned in the question, and each question is likely to have its own set of restrictions. So the first problem reads, 6 people, Andrew, Brenda, Corey, Danielle, Eliza, and Frank, are going to be seated in a line. How many unique lines can be formed if Frank must be seated first? So here, the fact that he has to be seated first, this is your restriction. Now, there is nothing that says in this question that repetition is allowed, so we're going to assume that repetition isn't allowed. So like it's mentioned in the steps, we're going to expand n factorial first, which in this case would be 6 factorial, since there are 6 subjects in this question. And we're going to deal with the restriction first. In this case, Frank must be seated first. So there's only one possibility in the first chair. And I'm going to number them accordingly here. 1, 2, 3, whoops, sorry. We're going to go 4, 5, and 6. Since the first chair is occupied, that leaves only 5 possible people left for the second chair. And then since none are supposed to be repeated, once the one person from the second chair has been decided, then there's only 4. And then the same continues, 3, 2, 1. And when we plug this in our calculator, we end up getting about 120 unique lines that can be formed. So now for part B, it says Brenda or Corey must be in the second chair and Eliza must be in the third chair. So what we're going to do here is, like we did the first time, we're going to expand our n factorial into 6 subjects or cases, and we're going to deal with the restrictions first. So we know that Eliza must be in the third chair first. So if I'm labeling the chairs as follows over here, then I'm going to put 1 for the third chair because only Eliza can be there. Now the second chair has 2 possibilities. It can be Brenda or Corey. So we're going to write 2 possibilities in here. Now, with that being said, the rest of them would get filled in as follows. The first chair has a possibility of 4 different people sitting in that chair, and that's because While Eliza is set, the second chair is occupied by one of the two people mentioned here. So once that one is decided, then there's still 4 options left for the first chair. So ultimately there's 4. Then once that has been decided, so we have 4, 3, then there will be 3 people left to go into this chair, 2 people left in this chair, and then 1 person left in this chair. This leaves a total of 48 unique lines formed when these restrictions are applied. And the reason why we went kind of down by 1 here is because remember, repetition isn't allowed. So for this question, how many ways can you order the letters from the word trees if the first restriction is a vowel must be at the beginning? So there are 2 vowels here, and one thing I will say is that this here is an identical or repeated object. So identical / repeated object, the E's are identical in the set. So that means that we're eventually going to have to use this formula here in order to properly solve the. Okay, so the first thing I did was I expanded this formula here. The n factorial, which would be 5, right? This has a possible of 5 permutations if there's no restrictions. And so because the first, there must be a vowel at the beginning, there's 2 possible vowels, well, the E and the E, that would go at the beginning. And then once one of them is decided, then there are 4 letters left for the second, way to order this. And then once the first 2 are taken up, then it's 3, and then 2, and then 1 as follows. That leaves us with a total of 48 ways. However, the E over here is repeated. So that means we have to use this formula, n factorial over r factorial, and this would be a step 2 kind of question. And so in this case, it'd be 48, which is equal to n factorial, over, it'd be 2 factorial since the e's repeat twice. And so the final answer over here would be 24, or 24 ways. So for part B of the question here, it says it must start with a consonant, which I've written over here that there are 3 of them, and end with a vowel in which there are 2. So the way we're going to approach this one here is if it must begin with a consonant, there are 3 possible ways that it can do that. And it has to end with a vowel, and there are 2 possible ways that it can do that since there are 2 E's over here. So we start with the restrictions. Then we're going to fill in the rest as appropriate. So this has to be consonant only, but then the rest of these can be consonants or vowels or both. So once we get rid of 1 consonant here, we have 2 consonants and a vowel to work with, which gives us another possibility of 3 for the second one here. And then we have 1 consonant and 1 vowel here since we can't repeat what's being used. So once that 1 consonant, let's say, is done, then we have a consonant and a vowel left. So then that'll be 2 over here. And then for the 4th, you could say object here, well, there's only 1 vowel left since all of our consonants would have been used up completely over here. And then it has to end with a vowel in which there are 2 possibilities for that. So we're going to go 3 times 3 times 2 times 1 times 2. And in that case, that is going to give us a total of 36. And that's what n factorial equals. Now, because there is repetition over here, we're going to go 36 divided by, or not repetition, but I should say there's an identical object of E. And so we're going to divide that by 2 factorial. And then ultimately, that is going to give us 18 ways for this part of the question over here. Lastly, the final restriction, if it begins with exactly 1 E, so as per usual, I've expanded my factorial into different parts of the set here. And we know that it's going to begin with exactly one E, and there are two E's that it could possibly begin with. So the beginning has a possibility of 2. And then from there, after 1 is chosen, then the rest is going to be figured out as. Now this would apply if, let's say, we decide to do vowels or consonants only. So consonants only, then that would give 3 consonants, and then over here you could have a consonant plus 1 vowel, so that'd be 2 consonants left plus 1 vowel. If this is all consonant, then we lose 1 to here, then we have 2 left, and then we have 1 vowel from there. And then of course the vowels are used up, so then we have, let's say we choose the vowel, then we have possible of 2 consonants over here. We use one of those up and we have 1 consonant over here. And so these are the possible measures. This equals to a total of 36. And since E is repeated, then we're going to use the formula like we did previously, 36 for our permutations, 36 over 2 factorial. And that, of course, gives us 18 ways